Hello students, so we will continue with the serial communication and its registers. So in the previous session we discussed SBUF register, SCON register. In this class we will be discussing about PCON register. Okay, so by the end of this class you will be you will know how to double the baud rate in 8051 using PCON register. Okay. Okay, so there are in fact two ways to increase the baud rate of the data transfer in serial communication. One is to use higher frequency crystal, and the second option is to change the particular bit in PCON register. All right. So using higher frequency crystal, it is not possible because since the crystal that is connected to the system is fixed and it cannot be changed every time, so the first option becomes invalid, or it is not appropriate to think about it. The second option to increase the baud rate is to change the particular bit in PCON register. So let us know what is PCON register. PCON register is a 8-bit register wherein here is the register as shown. So in this there is a particular bit called SMOD. Okay, so all other bits in PCON registers are used for power control capability of 8051. So we will not discuss about that right now. Okay, so we will stick on to SMOD bit. This SMOD bit is used in order like if you want to double the baud rate, then this particular bit has to be made 1, or otherwise when the 8051 is powered up, the D7 bit, that is a small bit of PCON register, will be generally 0. Okay, so when it is 0, then the crystal frequency what we'll have is what we discussed in the previous discussions, that is the machine cycle frequency will be divided by 32 by the UART circuitry. So what you will get will be 28,800 hertz. So that will be the frequency used by the timer 1 for programming the baud rate, or deciding the baud rate, right? So that is when SMOD is equal to 0. Okay, if you want to double the baud rate, then this SMOD bit has to be made 1. So how do we do that? See, since PCON register is not bit addressable, I'm sorry, like you have to use software method. It is bit addressable, so you have to use software method to program it. Okay, so the instructions are shown here. Move a PCON. That means you are copying the contents of PCON. Then you are setting the 7th bit of PCON register, which means in accumulator you are making that particular bit 1. Then you're sending back to PCON register. Okay, so directly you cannot change the particular bit in PCON. That is what I meant when it is when I said it is not bit addressable. So first you have to take it to accumulator, set the particular bit, and then move that information in accumulator to PCON. So therein the bits D7 bit, that is SMOD bit, will be made 1 in PCON register. So here is the explanation when depending on the SMOD status. See here, when SMOD is equal to 0, then usually the frequency 28,800, how we get, it was already discussed in the previous class. The crystal frequency divided by 12, the machine cycle frequency what you get, it is further divided by 32, then you get this 28,800 hertz. So that will be the frequency used by the timer 1 for serial communication. So when SMOD bit is equal to 1 in PCON register, then you will have double the baud rate, that is 57,600 Hertz will be the frequency that will be used by the timer. So here exactly what happens, the internal circuitry will be dividing the machine cycle frequency 921.6 kilohertz. It will be dividing it by 16. So what finally you get will be the double the baud rate. Okay. So this baud rate will be used by the timer 1. Alright. So observe the table here. The values will remain same. Okay. Only based on the SMOD status, when SMOD is equal to 0, so for the baud rate 9600, the value what you will be loading into TH1 register will be FD. So for 4800 FA, 2400 baud rate, you will be loading F4 and so on, right? So the values will be same, the hexadecimal values will remain same, but the baud rate will be double when S mod bit will be 1. Okay, so when you load FD into TH1 register of timer 1, and if at all S mod is equal to 1, then automatically the baud rate will be 19,200. Okay. Okay, so let us analyze one program here. Assume that XTAL is equal to 11.0592 megahertz for the following program. State what this program does. B. Compute the frequency used by timer 1 to set the baud rate. And C. Find the baud rate of the data transfer. Okay, let us analyze instruction. First instruction says move A, PCON. So the contents of PCON register is copied onto A register. Set bit ACC.7, that means the contents that is there in accumulator, the D7 bit, that is S mod bit, you are setting it, making it 1, and that you are sending it back to PCON register. So when you send like that, the S mod register you have made 1. So it means that you have programmed to use the double the baud rate. Okay, and of course with the same crystal frequency XTAL. Yeah, then you are saying move T mod with 20H, which means that timer 1 you are programming it to operate in mode 2 auto reload. Move TH1 you are loading with -3 decimal value, because which means that when you say S mod is equal to 1, the frequency used by the timer is 57,600, double the baud, double the frequency. Then say if you are loading -3, that means you are dividing it by 3, means you will get 19,200. So that is the baud rate what you are using for this particular serial communication. Okay, so that value are loading into TH1 register. So that answers the second question. B. Compute the frequency used by the timer. So the frequency used by the timer is 19,200. Then move SCON 50. So SCON register you're programming it with value 50, which means that the SM0 and SM1 you are programming it as 01, which means that you are programming serial communication to operate in mode 1. Mode 1 means the data is 8-bit size and there is only one stop bit, sorry, and the REN bit is enabled. REN bit is enabled. Okay. Then what are you doing? You are starting the timer. Then move A, B. That means the ASCII value of capital B is copied onto A. Then you are just clearing TI because you want to track it. Then the contents in A, is nothing but the ASCII code of capital B 42. That is in A, so that is sent to SBUF register. So now for every ticking, that is every clock pulse. Now the timer has already started. So for every clock pulse, every bit will be sent, right? So now you have to keep track of transmit interrupt bit. So that is what you're doing here in this loop, h_1. So you're polling, you're checking the transmit interrupt bit till it gets set. So when it gets set, which it means that the complete data is transmitted via TXD line. So make it clear that you are nowhere having any picture of TXD line, but it's basic. You should know that in serial communication, whether it is transmitting data or receiving data, it happens via TXD or RXD lines respectively. Okay, so once it is set, now when the TI bit is set, now you're out of the loop. Then you have to clear it by the software method, right? You clear it. Then if you want to do it, repeat it continuously, then jump back to A_1. So where again you are doing clear, it doesn't matter there. So you're sending that information again to SBUF. So that serially you are sending the capital B character. Okay. What is the third question? Find the baud rate. So what was the baud rate here? So baud rate is what you have calculated, 19,200. So that is the baud rate of this particular serial communication. I hope it is understood. Okay, students, let us review our understanding. I want you to answer these questions. So first question is, which timer of 8051 is used to set the baud rate? Which timer do you use to set the baud rate in 8051 for serial communication? It is timer 1, right? If XTAL is 11.0592 megahertz, what frequency is used by the timer to set the baud rate? What is the frequency? It is 28,800, right? How do you get that? First, you will divide the crystal frequency by 12 and the UART circuitry will divide again by 32. So when you, the final answer what you get is 28,800, yeah? Okay. So which mode of the timer is used to set the baud rate? Which mode of the timer is used to set the baud rate? That means which mode is the timer operating? Answer is mode 2, right? So timer 1 will be used for serial communication, where you have to program it to work in mode 2, right? That is 8-bit auto reload mode. Fine. Fourth question, with XTAL 11.0592 megahertz, what value should be loaded into TH1 register to have the baud rate 9600? What should be the value? So in order to get baud rate 9600, what is the value that you are loading into TH1 register? It is -3 decimal, right? So when you divide 28,800 by 3, then you get baud rate 9600. So how do you calculate that? So 28,800 hertz, you will divide by the baud rate required, that is 9600. So what you get will be 3. So that is the value, -3 in decimal and FD in hexadecimal. So that value you will be loading into TH1 register, right? Okay. Next, to transfer a byte of data serially, it must be placed in which register? It is SBUF register, right? So when you are transmitting, when you are receiving, both the ways, it will be, the data will be held in SBUF register, right? Okay. 6. SCON stands for dash and it is a dash bit register. What are the answers? SCON stands for serial control register, and it is a 8-bit register. Okay. Which register is used to set the data size and other framing information such as the stop bit? Answer is again SCON register, isn't it? In SCON register you have the selection of different serial modes. So serial modes decide how many stop bits, how many start bit, all those informations are there in the different modes. So that is given in SCON register, right? Then next question, PCON is a bit addressable register, true or false? It is, answer is false, right? PCON is not a bit addressable register. That's why you take it to accumulator first, then the set the bit D7 bit. If you want to have a double the baud rate, a small bit will be made 1 in accumulator, and then you send back it to PCON, right? Yeah. Next question, when is TI raised? Transmit interrupt. When is transmit interrupt raised? During the transfer of stop bit. Okay, so while you are sending data serially via TXD line, when the stop bit starts, when it is sent, half the way through the stop bit, the TI flag will be set to indicate that the transmission of 1 byte of data is completed. Okay, last question, which register has a small bit and what is its status when the 8051 is powered up? Of course, PCON register has a small bit, and what is its status when it is powered up? It is 0, right? When the microcontroller is powered up, SMOD will be equal to 0. Okay, so if you want to have double the baud rate, then you have to make it 1. I hope all these registers and programming 8051 for serial communication, it is clear. And I again request you, if you have any doubt, please mail me or send some message wherever you want me to repeat any of the things. If you have not followed the program, please let me know. Okay, I can explain again. So there is one more assignment where I'm expecting you to explain the program the way I'm doing now. Okay, so you have to take that program in the PPT, record as you're listening to my voice now, record in the same way and send it back. Okay, please go through the instructions. Thank you.